Okay, this is lesson 65, quadratic equations. We're looking at the widths, okay, the widths of them. Quadratic equations, when we graph them, they could vary in widths. And you've noticed sometimes, like if we have an x and y axis, we're just going to go really quickly. Some of the graphs look like they're opening up, and some of them look like they open down. How do you know if they open up or down? From the A, right? If A is positive, it opens up. If A is negative, it opens down, right? The other thing I want to teach you today, and specifically, is we're going to look at A, and the farther A is from 0, the thinner it is. The closer it is to 0, the wider it is, okay? And what I mean is, what is A? We always figure out what A is. So, we have to ask ourselves what A is on the number line today. So the big picture you have to know is the closer it is to 0, if this is 0 on the number line, this is 1, 2, 3. This is negative 1, negative 2, negative 3. Okay? 1, 2, 3, and negative 1, 2, 3. If I have a point here at 1 and I have a point here at negative 2, which one's closer to 0? 1. So 1 is going to be wider than negative 2. Does that make sense? It's going to look wider when we draw it. Wider. You know how to use? Wider. W-I-D-E-R.
Like 1 and then like 2?
Yeah, it's kind of backwards. 2 is thinner and 1 is wider. That's why it's confusing.
That makes no sense.
That's why you have to look at a number and look over here. So every number, let's say you have a number that's 1 and negative 3. Negative 3 will open down, but it'll be very thin. 1 will be opening up and it'll be wider. Okay? When we see it, you'll see it'll work out. Okay? Here we go. Here are the steps. Identify A. You're all really good at that now. And here's the rule. Did you all write these steps down? The closer a number is to 0, the wider the graph. The farther a number is from 0, the narrower the graph. Okay? So, here we go. If I were to graph these three different functions, or these three graphs, the first one, number 1, would look like as follows. Okay, I'm just going to graph it really quickly so you could see. Okay, this is number 1. Okay, this is graph number 1. What is A equal to in number 1? A is equal to 1. Okay, good. What's A equal to in number 2?
Negative 2.
Negative 2. Okay, since you know it's negative, which way is it going to open? Up or down? Down. Okay, so if I were to graph number 2, I want you to notice something about number 2. What do you notice the difference between number 1 and 2 is? Is this one, do you notice how this one is wider? Yeah. Do you know how this one is more narrow? So isn't negative 2 bigger than 1? Would you agree? The distance from 0, wouldn't you agree? So the bigger the number is from 0, or the farther it is from 0, the more narrow it's going to get. Does that make sense? Yeah. So let's look at number 3. What's A in number 3? 1/2, okay? A equals 1/2, okay? So this is what number 3 is going to look like. If I were to graph it, or you were to graph it, it looks like this. Okay? Now what do you notice about this one? It's wider, right? Isn't 1/2 closer than 1 to 0? Would you agree?
Yes.
So A tells you two things. A tells you if it opens up or down. How do we know if it opens up? Positive, right? How do you know if it opens down? Negative. How do you know it? How do you know if it's going to be fatter? How do you know it's going to be a fat graph or a wide graph?
If it's shorter to if it's closest to the
Closer to 0, right? So if it's a fraction, it'll be closer, okay? So that's basically the concept. Okay, so why don't you turn your neighbor ones till the twos, just remind them of how do you know if it opens up or down, and then twos till the ones, how do you know if it's going to be a wide graph or a narrow graph? Ready, set, go. So the concept is if A is closer to 0, it's going to be wider, okay? So the next one, we know it's either going to open up or down, or if it's going to be wider or narrower, okay? Or more wide or more narrow. So look at number 3. Let's all read the directions above number 3 together as one. Ready? And begin. Order
the following from widest to most narrow.
Okay, good. So, on this last one, I'm going to change this. It's going to be 2/5, okay? 2/5. Okay, so, on the first one, what's A equal to here on the first one?
2/3.
2/3. Okay, what's A equal to on the second one?
1/2.
Good. What's A equal to on the third one? Okay, good. So, which one is the closest to 0? 2/3, 1/2, or 2/5? Turn to your neighbor, discuss it, and I'm going to ask you which one's the closest, and then which one's the next closest, and which one's not the closest. Okay? So raise your hand if you believe 2/3 is the closest to 0. Raise your hand if you say 1/2 is the closest to 0.
Oh my god.
Raise your hand if you say 2/5 is the closest to 0. Okay, good. 2/5 is the closest to 0. So since it's the closest, it's going to be the most wide, okay? Or the widest one, okay? So you write that one first. This is going to be the first one you write. Y is equal to 2/5 x squared plus 5. That's the first one. What's the next one? Raise your hand if you think the first equation is the next one. Raise your hand if you think it's the second equation. Good, it's the second one. So this is the next widest. Okay, what's the third equation? Of course, it's the last one, which is the 2/3, right? Y is equal to 2/3 x squared plus 5. Okay? That's it. Pretty easy, right? Let's do one more. Number 4 here. Number 4. Turn your neighbor and tell them what the order should be from most wide to most narrow. Even though 20 looks like the biggest, it's the most narrow. Okay, so you got to think backwards. If it's big, it's not the widest. It's narrow. Okay, so the first one we write is the widest, so it's going to be y is equal to negative 2/3 x squared plus 2. Next one is going to be y is equal to negative 2x squared plus 2, and the last one is going to be y is equal to negative 20x squared plus 2. Now I got a question for you. Which way are each of these going to open?
Like that, so we take off his head.
Which one? Or which way are they going? They're opening down, right? Do y'all agree?
Yeah.
Down.
Down.
Okay. I'll do that. All right, so that's the end of our lesson. So turn to your neighbor, tell him, what did we learn? How do we do that? I'm going to call on you. How does this fit into mathematics, and how might we use this in real life? Ready, set, go.